In this video, I'll show you how to configure both Docker Agent Autoscaling and Windows Autoscaling on Kasm with a Nutanix backend. Autoscaling is a feature in Kasm that allows you to dynamically provision and deprovision new agents and servers based on real-time user demand. Watch the Autoscaling overview video to learn more about what is Autoscaling and how it works in Kasm. In this demo, I'm running Nutanix Community Edition 6.8.1 on a single node cluster with Prism Central version 2024.3.1.1 deployed to centrally manage the Nutanix environment. Before we get started, it's important to go through the prerequisites on our documentation to get Nutanix Autoscaling to work on Kasm. You need to have admin access to your Nutanix environment. You need to have an identity provider or a directory service configured. You need to have 2 user accounts, one for administrating the project and creating VMs, and one to interact with the Nutanix APIs. You also obviously need to have Kasm Workspaces installed. The first step is to create a Nutanix role. To do that, go to your Nutanix Prism Central, go to the Admin Center, and then click on IAM. Now go to the Roles tab and create a new role. Start by giving your role a name, and then assign the appropriate permissions. The set of required permissions depends on whether you're using the Nutanix v3 API or the v4 API. You can find the exact permission requirements for both in our documentation. We recommend using the v3 API because it is more stable, and I'll be using the same in this demo. Some permissions may have dependencies on other permissions. When this happens, a pop-up will appear suggesting the additional recommended permissions. You can simply accept these to proceed. Once you add all the permissions, simply click Save and Create Authorization Policy to create the role. You can now simply close this window and cross-check whether your new role has been created. We now need to create a new project on Nutanix. But before that, Nutanix requires the users associated with the project to be backed by an SSO. In this video, I'll create an Active Directory identity provider. To do that, I'll navigate to the Admin Center, go to IAM, then select IDP configuration, and click Add Identity Provider. From the list of available options, I'll choose Active Directory/OpenLDAP. Over here, I'll name my identity provider, specify the domain, and also enter the LDAP URL. You can use either LDAP or LDAPS here. Next, I'll set the search type to non-recursive. And finally, I also need to provide the credentials of a service account so that Nutanix will be able to query my Active Directory. Click Save, and a new Active Directory identity provider is now created. Now that an identity provider is configured, we can go ahead and create a project. To create a new project, go to the Admin Center, then click on Projects in the left menu. Click Create Project, give your project a name, and then click Create to create the project. Now click on the Created Project and go to the Users and Groups tab. Over here, you will need to add 2 new users. The first user will administer the project and perform tasks like creating the VMs. Make sure you set the role of the first user to Project Admin. The second user will be configured in Kasm to access the Nutanix APIs. Make sure you set the role of this user to the role that you created earlier. Also make sure that Allow Collaboration is enabled and then click Save. Now go to the Infrastructure tab, click Add Infrastructure, and then select the endpoint that will be used to provision Kasm Autoscale resources. Click on Configure Resources and select the cluster that you want to use. Also add the corresponding VLAN for the selected cluster. Now that the project is set up, let's move on to configuring Docker Agent Autoscaling on Nutanix. Before we can set that up in Kasm, we need to create a template VM in Nutanix. This template will be used as the base image for any autoscaled resources that get deployed. On the Nutanix Prism Central, go to Infrastructure, Computer, Images, and then click Add Image. You can either upload the ISO image file or paste the URL of the file and Nutanix will download it for you. In this demo, I'm using the Ubuntu Noble image by downloading it directly from this URL. The image may take a few minutes to upload. You can look at the task history to track the progress. Once the image is uploaded, we need to create a new VM from this image. Go to Infrastructure, Compute, VMs, and then click Create VM. I'll call it Kasm Ubuntu template. Make sure to assign this VM to the project that you created earlier. Define the number of cores and memory you want to allocate to your VM and click Next. In this screen, attach a disk to your VM with the appropriate disk size you want to allocate. Make sure you also set the bus type to SCSI and click Save. This disk is for the boot volume. We also need to attach another disk with the ISO image. Click Attach Disk once again and set the type to CD-ROM. In the operation, select Clone from Image and then select the Ubuntu ISO image file that you uploaded. Similarly, I also need to attach the VM to a subnet. So I'll choose the default subnet and make sure the connection state is set to connected. You can also attach a vGPU here if you want, but we will not be doing that in this demo. Click Next. We will not be making any changes in this screen, so click Next again. Finally, review your options and click Create VM to provision the VM. Once the VM is provisioned, power it on and launch the console. You can now follow the on-screen instructions to install Ubuntu on your VM. During the installation, make sure to select Install OpenSSH Server when prompted. You don't need to install any other additional tools from the menu. Once the installation is complete, click Reboot Now to reboot your VM and boot into the installed operating system. After logging in, you need to set a root password so that when new VMs are created from this template, you will be able to log in to the created VMs using your root password for troubleshooting purposes. We'll then need to run a few cleanup commands to prepare this VM as a reusable template. This includes removing machine-specific identifiers and the cloud init logs so that each cloned VM starts with a clean state. Finally, shut down your VM. Once the VM is completely powered off, right-click on it and select Update. Click Next and then remove the CD-ROM disk which contains the Ubuntu ISO image and save the VM. Now that we have created an Ubuntu template on Nutanix, let's go ahead and configure autoscaling on Kasm. The first thing you need to do is go to your Kasm admin panel and then go to Infrastructure, Zones. Edit your zone and you will see the upstream auth address is set to an internal name called proxy by default. You need to change this value to the actual IP or fully qualified domain name of your Kasm deployment so that the autoscaled VMs will be able to talk to Kasm. If you're using a multi-server or a multi-zone deployment, you may need to set this to your load balancer's IP or domain name. Refer to our docs for more information. Next, let's create a pool. Go to Infrastructure, Pools, and then create a new pool. Make sure you set the pool type to Docker Agent since we are doing Docker Agent Autoscaling. Next, we need to create an autoscale config and assign it to the created pool. Edit the created pool and then go to the Autoscale Configurations tab and click Add. Name your autoscale config, set the type to Docker Agent, and select the pool that you just created. Also, select your deployment zone. Downscale backoff is the amount of time Kasm will wait before it downscales your resources when there is a surplus. I'll set it to 60 seconds. To learn more about what these options mean in more detail, watch the autoscaling overview video. Standby cores represent the number of CPU cores that Kasm will always try to keep available. If the number of available cores fall below this value, Kasm will automatically provision new resources. Similarly, if the number of available cores rise above this value, Kasm downscales existing resources to cut compute costs. I'll set this to 2 cores for this demo. The same logic applies to standby GPUs and standby memory. Agent Cores Override allows you to manually specify how many CPU cores Kasm should treat the VM as having, regardless of its actual core count. You can override the actual number of available cores with this value depending on your use case. Once again, the same logic applies to Agent GPUs Override and Agent Memory Override. Click Next, and this is where you configure your VM provider specific details. Set the provider to Nutanix and give it a name. Max instances lets you define the maximum number of instances you want Kasm to be able to provision on your Nutanix environment regardless of computing needs. I'll set this to 5. Next, enter the host of your Nutanix Prism Central. This can either be the IP or fully qualified domain name of your Nutanix Prism Central. Also, enter the port of your Nutanix Prism Central, which is 9440 by default. It is also important to make sure that Kasm can actually talk to your Nutanix deployment. Next, you need to provide Kasm with the username and password of your Nutanix user that you added to the project earlier. This account will be used to interact with the Nutanix API. To find the user account, go to your Admin Center, Projects, select your project, and then go to the Users and Groups tab. In this demo, Nutanix Autoscale is a user account I imported from my Active Directory to use with Kasm. So I'll enter the username and password of this account in Kasm. In this demo, since I don't have SSL certs installed on my Nutanix deployment, I'll disable Verify SSL. But in an ideal production scenario, you want to have this enabled for secure communication. I'll set the API version to 3, which is what we recommend using. We also support v4, but it is still in technical preview at the moment. The VM candidate is the name of your Ubuntu virtual machine that you created for templating. You can find it by going to Infrastructure on your Nutanix dashboard, go to Compute, and then VMs. You can then define the number of cores and memory you want to allocate to each provisioned instance. Finally, you can define a startup script that will automatically be executed on the VM as soon as it's provisioned. The main goal of the startup script is to download and install the Kasm Agent role and then connect back to your Kasm deployment, so that Kasm will be able to register and control the newly provisioned agent. We publish templates for these startup scripts on our public GitHub repo. Check out the description for the link. Make sure you choose the correct version of Kasm you have installed and then go to the Docker Agents folder. For Nutanix, we'll use the ubuntu.sh script. Click Finish and your autoscale config is now complete and is active. This should automatically trigger autoscaling, and Kasm will begin autoscaling agents to satisfy the set standby values. As you can see on my Nutanix dashboard, a new VM is being provisioned by Kasm. In Kasm, if you go to Infrastructure and then Docker Agents, you can also see the provisioned agent listed here. Initially, its status will show as starting, which means the VM has been created, but the Kasm Agent role hasn't finished installing or checked in with the Kasm deployment yet. Once the check-in is complete, the status will change to running, and this means that the agent is now ready to accommodate new sessions. To test this, you can disable the default static agent named Proxy, so that new sessions will automatically be created on the autoscaled agent. Let me go ahead and launch the Firefox workspace that I already downloaded. As you can see, the session is successfully launched. Now if I go back to Infrastructure and then Docker Agents again, you can see the autoscaled agent shows that it has one session active, which is the Firefox session. You can also see the number of cores on this agent are used up by the Firefox session, so Kasm automatically triggers the autoscaling job and provisions a new VM on Nutanix. Once the new agent comes to the running state, I will now be able to launch additional sessions. Let me now go ahead and delete both the sessions. Kasm will now detect that there is a surplus of compute resources and it automatically deprovisions an agent. The same can be verified on Nutanix. As you can see, one of my autoscaled VM is now deleted. Sometimes your agents may fail to check in to Kasm even though they are provisioned on Nutanix. To troubleshoot this, you can directly launch a console of the autoscaled VM on Nutanix and log in with your root user. You can first check the cloudinit output logs located at var/log/cloudinitoutput.log. Here you can see if the startup script executed successfully or if it produced any errors. As an example, I intentionally made the script produce an error, which you can see here. You can look at the errors in this log to get an idea of why the startup script is failing. Another thing that you can do is you can look at the actual startup script that got executed on the VM. which is located at var/lib/cloud/instance/userdata.txt. The startup script we provided on Kasm is templated, and Kasm automatically injects certain values into this script when passing it to the VM. So you can have a look at the startup script here to find any misconfigurations that are preventing the agent from checking in. You can also manually execute this bash script to troubleshoot it. As you can see, I intentionally included an exit statement in the script as an example, which is why the script is failing to execute and produce the error that we saw on the cloud init logs. To reset your autoscale config and delete all your autoscaled agents, go to Pools, edit the pool, and then go to the Autoscale Configuration tab. Edit the autoscale config and set all the standby values to 0. Kasm will now wait for the configured downscale backoff time, which is 60 seconds in my case, and then deprovisions all the autoscaled agents. To do Windows Autoscaling on Nutanix, you'll first need to create a Windows VM template, just like we did earlier with the Ubuntu VM. In this demo, I'll be using the Windows Server 2025. I need to upload this ISO image to Nutanix so that I can create a VM from it. I'll also need to install the VirtIO drivers for proper storage and network support. So I'll need to upload the ISO file for the VirtIO drivers as well. To upload the ISO files, go to Compute, Images, and then click Add Image. First, upload your Windows Server 2025 ISO file, and then you can rename it to something simple. Next, click Add Image again, and this time upload the VirtIO ISO file. You can look at the task history to track the progress of these uploads. Once the images are uploaded, go to VMs and then create a new VM. Give it an appropriate name, select the project that you created earlier, and set the number of cores and memory you want to allocate to the VM. Click Next and attach a disk to your VM. Specify the amount of storage space you want to allocate to your disk. I'll set it to 150 gigs for this demo. We need to add another disk to mount the Windows Server ISO. Set the type to CD-ROM, operation to clone from image, and then select your uploaded Windows Server ISO image. Make sure the bus type is set to SATA and click Save. Similarly, we also need to add a disk for the VirtIO drivers. Click Attach Disk again, set the disk type to CD-ROM, operation to clone from image, and then select your VirtIO ISO image. Click Attach to Subnet to attach the VM to a subnet. In this demo, I'll attach it to the default subnet. Make sure the connection state is set to connected and click Save. Make sure you also enable UEFI BIOS mode, secure boot, and attach VTPM. You can also configure a vGPU here, but it's out of scope for this video, so I'll not be doing that. Click Next. You don't need to make any changes in this screen, so click Next again, and finally click Create VM. Once the VM is created, power it on and launch the console. Now, follow the on-screen instructions to install the Windows Server 2025. Make sure you install the Windows Server 2025 Standard with desktop experience. You need to install the VirtIO storage controllers first for the Windows installer to properly detect your disks. Click on Load Driver and then click Browse. Go to your VirtIO disk and then go to the VIO SCSI folder. Expand 2025 and then select the AMD 64 folder. Click Install and this will install the appropriate storage controllers for Windows Server 2025. Once the drivers are installed, you can now see the Windows installer has detected your disk. Click Next and continue with the installation. Set a password for your administrator account. Once the installation is complete, log into your VM with your administrator account. The first thing you need to do after your first boot is to install the VirtIO drivers. Open your File Explorer, go to the VirtIO disk, and execute the installer. Once the drivers are installed, go ahead and download Cloud Base Init from your browser. This tool is used by Kasm to run startup scripts when a Windows VM is provisioned. Next, open your server manager and go to Local Server. Click on Remote Desktop and select Allow remote connections to this computer. Apply and save the settings. You can now install any additional software that you'd like to have on your autoscaled Windows VMs. For example, you can install Microsoft Office now if you'd like to have the Office tools on all your autoscaled VMs. Finally, go ahead and shut down your VM. Once the VM is powered off, right-click on it and click Update. Go to the Resources tab and remove both the Windows ISO disk as well as the VirtIO ISO disk and save the VM. Now that we have created a Windows template VM, let's go ahead and configure Windows Autoscaling on Kasm. On your Kasm admin panel, go to Infrastructure, Pools, and then create a new pool for the Windows servers. Make sure you set the type to Server. Edit the created pool, go to the Autoscale Configurations tab, and click Add. Give an appropriate name to your autoscale config. Select the deployment zone as well. I'll set the downscale back off to 60 seconds. I'll enable Kasm Desktop Service installed, which also automatically enables Require Server Check-in. You need to have these options enabled if you plan on installing the Kasm Desktop Service on the Windows VMs and want the VMs to check in with your Kasm deployment, which is exactly what we'll be doing in this demo. Installing the Kasm Desktop Service offers you with additional features like the ability to create dynamic local accounts on your Windows VMs, uploading and downloading files, etc. Set the connection type to RDP and the connection port to 3389. For the connection credential type, I'll choose Dynamic User Accounts, which tells Kasm to create a new local Windows account based on the Kasm user whenever a session is requested. You also have the option to mark the VMs as reusable or not. If you enable reusable, it means the same Windows VM can be reused by multiple users. If it's disabled, the VM will be automatically destroyed once a user ends their session, ensuring a fresh environment each time. I'll leave it disabled for this demo. You can then configure the minimum available sessions you want to have around, and also the maximum simultaneous sessions you want to allow per each server. Click Next, and now it's time to configure your VM provider specific details. Choose the provider as Nutanix and give it an appropriate name. I'll set the max instances to 5. I'll then fill in my Nutanix Prism Central host and the port, which is 9440 by default. Once again, it is important to make sure that Kasm can talk to your Nutanix deployment. Just like with the Docker Agent Autoscaling, you need to provide Kasm with the username and password of your Nutanix user that you added to the project earlier so that Kasm will be able to interact with the Nutanix API. To find the user account, you can go to your Admin Central on Nutanix, go to Projects, select the project, and then go to the Users and Groups tab. As you can see for this demo, I imported 2 users from my Active Directory. I'll use the Nutanix Autoscale user for interacting with the APIs. So I'll fill in the username and password of this user in Kasm. I'll disable Verify SSL since I don't have SSL certs installed on my Nutanix deployment. I'll set the API version to v3, which is the stable one and the recommended option. For the VM candidate, I need to enter the name of my Windows VM template that I just created. To find the name, you can go back to Infrastructure on Nutanix, go to Compute, and then VMs. Next, define the number of cores and memory you want to allocate to the provisioned VMs. Finally, you can insert a startup script that will get executed on the VM as soon as it's provisioned. We have a public GitHub repo where we publish examples of these autoscale startup scripts. The link will be in the description below. I'll go to 1.17, which is my Kasm version, and then go to Windows VMs, and I'll use the default Kasm Desktop Service startup script. This script basically downloads the appropriate version of the Kasm Desktop Service, installs it, and registers it with my Kasm deployment. Click Finish, and your Windows Autoscale config is now active. You can see Kasm has provisioned a new VM on my Nutanix. You can also see this in Kasm if you go to Infrastructure and then Servers. The autoscaled server will be listed here after a few minutes. The initial state for the server is starting, and it will be changed to running once the autoscale startup script executes, which in turn installs the Kasm desktop service and checks in with the Kasm deployment. Once the status is changed to running, it means that the server is now usable and can accommodate sessions. To use this server, we first need to create a workspace. To do that, go to Workspaces and then click Add Workspace. Set the workspace type to Pool. We'll call the workspace as Windows Desktop since it's supposed to give the desktop experience of Windows. Select the Windows Server pool that you just created. We'll choose the Web Native Client for the RDP client options, and finally click Save. I'll now go ahead and launch the Windows Workspace. And as you can see, I am now able to create a session on the autoscaled Windows server with a dynamically created local user account. Since we disabled reusable in the autoscale config, Kasm is now going to trigger the autoscaling job and provision a new Windows VM on Nutanix since there are no available fresh Windows VMs to create sessions on. So if I go back to my servers, you can see a new server is provisioned by Kasm. If I now delete my existing Windows session, Kasm will automatically delete this Windows VM since it's not reusable. Once again, if I go back to my servers, you can see the status of the first autoscaled Windows VM is changed to destroying, which means that Kasm is deprovisioning it automatically. Sometimes you might encounter issues where your autoscaled servers get stuck in the starting state and never transition to the running state. When this happens, Kasm will automatically destroy the server if it doesn't reach the running state within a configured timeout period. This timeout value is defined in your global settings under the option called Provision Timeout. You can launch a console of your VM directly from Nutanix to troubleshoot this. The startup script passed by Kasm gets placed on a CD-ROM that gets mounted to your VM during provisioning. Open your File Explorer inside the VM and then navigate to the CD-ROM drive. Then go to the OpenStack folder and open the file named User Data. This file contains the PowerShell startup script that you configured on Kasm. Kasm automatically injects variables from your Kasm deployment into this script, so it's worth reviewing this file for any misconfigurations. You can also try running the script manually in PowerShell to help pinpoint the issue during troubleshooting. You can also look at the cloud-based init logs to understand why the startup script failed. You can find the logs in your C drive, program files, cloud-based solutions, cloud-based init, log, and then open the file named cloud-based init. You may also want to check the Kasm desktop service logs if you know that the installation was successful but the VM failed to check in. You can find these logs in program files, Kasm, and you can find the log file here. One more thing you could do is you can check whether the Kasm desktop service is running by opening your services and looking at the status of your Kasm service. You can also take a look at the event viewer to see the logs generated by both the startup script and the Kasm desktop service if it's installed. Now let's see how to configure and use Windows RemoteApps in Kasm. Before we dive into that, you may want to disable the Windows out-of-box experience so that users don't encounter the initial setup screens like choosing region, keyboard layout, creating local accounts, etc. To do that, you need to make some changes to your Windows VM template. Power on your VM and log in. Next, open the registry editor. Go to hkey_local_machine, Software, Policies, Microsoft, right-click on Windows and create a new key. Name it OOBE, which stands for Out-of-Box Experience. Create a new dword value here and name it Disable Privacy Experience and set its value to 1. Next, go to Data Collection and create a new dword value here. Name it Allow Telemetry and set its value to 0. Now go ahead and shut down your VM. Now, to create a new remote app workspace, go to your Kasm admin panel, go to Workspaces, and then click Add Workspace. Set the type to pool just like before. I'll name this Microsoft Edge because I want to host the Microsoft Edge remote app with this workspace. Select the Windows Server pool, and then set the RDP client options to Web Native Client. I'll enable Remote App and set the friendly name as Microsoft Edge once again. For the remote app program name/path, I'll paste the path to my Microsoft Edge binary on the VM. If you're using an RDS server, you need to input the name of your published remote app here instead of the full path. Finally, click Save and the Remote App workspace is now created. Let me go ahead and launch it. And as you can see, Microsoft Edge is now launching seamlessly inside the Remote App session. Thanks for watching the video. All the links to the appropriate docs and guides will be provided in the description below.